Who might have felt that only 120 light-years from us, there would be a planet on which the principal indications of life have now been found. By and by, we are managing an outright work of art of the James Webb Space Telescope. This wonder of innovation looked with its sharp eyes at a far-off world and found the main indications of extraterrestrial life there. The exoplanet K2-18B has been stunning science, starting from the main examinations. This planet is evidently a rich water world and could harbor far more life than our Earth. K2-18B is an exoplanet that has already earned its place in the history books of astronomy. A little more than 120 light-years from us, the planet orbits a red dwarf star. K2-18b gives several significant indications of biological processes, making it one of the most pursued objects of study today. James Webb was able to identify 4 markers of life forms in the planet's atmosphere. Thus far, this is considered an absolute exception. The exciting report now energizes many hopes of finally finding true life in the universe. Due to the precise spectrometer analyses by James Webb, researchers quickly observed that this world plays an extraordinary role among exoplanets. When the study showed evidence of abundant water at the start of the research, the scientists were already astonished. What followed could change our science forever. For the first time, we are looking at a planet that can answer the questions of what life truly is and how it arises. Besides, this world could prove to us that the diversity of life in the universe is greater than we had previously imagined. The questions of how many life forms exist in the universe and what they look like are not just of interest to scientists but also to many ordinary people. With the investigation of K2-18b, we may be on the verge of answering these questions for the first time. For biomarkers not only provide evidence of a world rich in water, but also, for the first time, offer compelling evidence of the presence of extraterrestrial life in the atmosphere of K2-18b. Evidence of methane and carbon dioxide was found, among other things. The two gases, especially when they occur together, are clear signs of biological processes and life. Dimethyl sulfide DMS on K2-18b further supports the evidence of life. Methane and carbon dioxide, together with water, could already be described as a jackpot in the search for life in the universe. Another find raises the stakes. We now have the first spectrometer analysis of a planet that shows such strong indications of life that the discovery is considered a scientific sensation. The gas that is unequivocally considered evidence of life is dimethyl sulfide, or DMS for short. On Earth, this gas is produced during the metabolism of algae and occurs in large quantities near oceans, seas, and large wetlands. The discovery of DMS on a distant planet implies, at the very least, that there must be life in the expanses of this exoplanet. Algae are the simplest life forms on our planet, and likely populated ancient Earth seas well before the first basic fish, snails, and mollusks appeared. Algae were likely the precursors to complex life, and these plants may hold one of the keys we need to understand the evolution of life. The presence of DMS on K2-18b can be seen as evidence that algae exist in the planet's oceans. Where there is algae, there can be further life. Despite the sensational nature of this discovery, it is still being treated cautiously. Trustworthy scientists are hesitant to declare the finding of the first aliens, even though all signs point in that direction. DMS, together with methane, carbon dioxide, and large amounts of water, are serious indicators of the first habitable planet we have discovered in the universe. Let us explore the gas methane further. Methane is closely associated with life, and the prospects for life on K2-18b increase significantly. James Webb's precise spectrometer analyses revealed a combination of methane and carbon dioxide, which signals a biologically active world. By comparison, Saturn's moon Titan also has abundant methane, but lacks other biomarkers such as water or oxygen, making it likely uninhabited. Alternatively, there might only be extremely simple methane-based microorganisms. Whether oceans with warm water and algae eventually produce higher life is one of the great mysteries of the evolution of life. This is precisely what we aim to uncover. The intriguing discovery of biomarkers in K2-18b's environment could be another crucial step toward understanding how life arises in the universe and how it spreads on planets. Methane is predominantly produced by microorganisms. Other significant sources include the gastrointestinal tracts of ruminants and large rice paddies. Methanogenic microorganisms do not live in methane but produce it as part of their metabolic processes. Along with DMS, the methane reserves on K2-18B indicate at least one thing: abundant vegetation. On Earth, algae and some phytoplankton species produce large amounts of DMS, which can then be found in our planet's atmosphere. The dimethyl sulfonium propionate is produced by decomposition processes in coastal ecosystems and enters the atmosphere from there. What exactly does the surface of K2-18B look like? Unfortunately, with our current technology, we are not yet able to observe the surface of exoplanets directly. The James Webb Telescope uses its spectrometers to analyze the light that distant planets absorb from their stars and then re-emit. These interactions create a unique pattern of light in different wavelengths. Water and oceans reflect light differently than forests, mountains, or deserts. The Webb telescope can examine the light in the planet's environment for gases and thus identify biomarkers such as methane and DMS. Regarding K2-18B, with our technology, we can only see a kind of light fingerprint of the planet rather than an exact picture of its surface. We observe the vapors of its seas and the metabolic byproducts of algae or single-celled organisms. However, we cannot yet directly see these living things or determine what they look like. Data from the James Webb Space Telescope indicates that K2-18B is a massive water world about 8.6 times the size of Earth and covered in a thick hydrogen atmosphere. This planet belongs to the so-called Hycean worlds, a recently identified category of planets in the universe. The discovery of Hycean worlds was quite a surprise because scientists previously assumed water in the universe was relatively rare. The emergence of this new class of planets felt like cosmic flying water droplets suddenly appeared before the researchers' eyes. Hycean worlds are significantly more water-covered than Earth and much larger than typical rocky worlds. These characteristics make this type of planet particularly exciting because where there is abundant water, the likelihood of life is extremely high. These planets are often hotter than Earth and could function as massive warm greenhouses. If they are not too hot, they would provide ideal conditions for the emergence of abundant life. Imagine ocean-covered superworlds teeming with life in their waters, resembling the most colorful reefs in our oceans. We also cannot rule out the possibility that such a world could develop higher living organisms bound to the water. Civilizations that inhabit water worlds could be unique hybrid creatures, part fish, part intelligent beings. K2-18B may represent the first evidence of abundant life in the universe, and we can hope that our science fiction dreams of colorful aliens and vibrant ecosystems will soon become a reality. We must wait and see. At present, scientists are working on new technologies that will allow us to analyze biomarkers and metabolic products on distant planets even better, enabling us to determine whether there are further similarities to life forms on Earth. Iron really reigns on this planet, and these vanishing and gathering metal clouds create the exact conditions for a brilliance effect. Researchers suspect that when the light of the nearby star hits these iron clouds, it is reflected and dispersed, creating the ring-shaped glow around the planet. However, we now need to examine the actual impression of the glow effect on this world, because the glow around JWST is not just a fascinating sight, but also an indication of exotic physical processes occurring near this planet. Such bizarre processes are taking place that they challenge the very fabric of absolute physics. With the James Webb Space Telescope, we have been able to detect increasingly strange effects on exoplanets. Some researchers have begun to question whether we can truly begin to describe and understand the universe using our current, established physics. We find exceptions to the rules by the dozen, and the universe is increasingly resembling a wild jungle of anomalies, impossibilities, and scientific emergencies. Subscribe to the channel now, and stay tuned for every new video.